So I'm going to walk you through a machine learning model that I built. So the focus of this is thyroid cancer research, and we're looking at predicting thyroid cancer risk, basically on a series of indicators. Our data was taken from Kaggle, and this is the link here. So again, the purpose of this model is to predict, based on specific indicators, if a person is or is not at risk for thyroid cancer. And the reason I'm doing this is because predicting thyroid cancer risk allows for early intervention. An accurate prediction can lead to better treatment, lessen severe development of the disease, and possibly prevent the disease from manifesting. So for my data preparation, I built a Tableau dashboard. And one of the things in the original data set, the data was divided into low, medium, and high risk. And then for simplicity of this machine learning model, I changed that to just is or is not at risk. So low became 0 and medium and high became 1. At the bottom, you'll also see that we had 17 model features. So these are the health indicators. This is my my Tableau dashboard, and what you're going to see here is the bigger, the larger group were actually female, and India had the highest risk. Oops. So if we go back here. So the next thing I did was I did some research based on costs of cancer during the different phases, and this is the link to the study, and basically it identified a reasonable estimate of the financial cost of thyroid cancer by stages. So you'll see them by stages here, the totals, and in this study there were 687 participants, so that's what I divided it by to get an individual cost. So the initial phase is 982, the continuing, so if they had cancer per year, it was 887, and then end of life, it was, kind of stage 5, etc. So so for the high risk people, so people that had continuing, we did this multiplied by 5, because usually with the cancer, 5 years is kind of a general rule. So what that ended up giving us was a total cost of $4,961. So that would be the cost per person that we would save if we caught the cancer early. And that would be the cost that it would cost us. So if we had a false negative, this would be the cost per person. So, yeah. So then what I did was I went into Data Robot and built my model, and I'll go into Data Robot here and show you. So this is the one that I ended up picking. And if you look at the ROC curve here, we have a prediction value of 0.9469. That's pretty high. And then what I also did was with the payoff. So this is based on the research, $4,961. So if let's do select messages. So, and this one here. So we would actually save $1.41 million if we caught all the true positives. And then if we caught, if our model predicted false negatives properly, it would save us $2.91 million. So that's kind of a lot. The other thing I did with this as well is an application. And let me go back here first. So this is the Optimizer app. So based on the research, I built a thyroid cancer risk optimizer. Basically, we can fill it in and change the values. So let's just do 0, 0, 0. just for 0.5, 15. There's a little bit more. 0. Let's do 10, 0, and 0. So then what happens is you play with this, and it gives you the result based on our model of whether or not they are at risk for cancer. So you see this one, based on those numbers that we picked, this person has a 99.22% risk of developing cancer, thyroid cancer. So it's a kind of fun way to play with this. If you go back, so we just do, so you can just add another one and change it. It's kind of fun. So yes, so this is just going back to the model that I ended up choosing. So it's CareSlim Residual Neural Network Classifier using a training schedule. Also, my model was a binary classification. Remember, we changed it from low, medium, high to just is or is not at risk. So the model score was pretty high. The F1 is 0.9629. The true positive is 0.9795. Precision recall is 0.9569, so it's pretty good. Our original data had 212,692 participants, so that's pretty good. And then again, going back to our profit based on the model, with this data set and based on this model that I created, the cost for false negatives would be 2.91 million, and if we the savings if we got true negatives would be 1.41 million. So thank you for listening.